only do what some people call useful research. We should know more. This is our main job. But we should also look with attention at the possibilities of translating this knowledge into useful application.
Two years after finishing medical school in 1972, Roberto Di Lauro moved to the U.S. for a postdoc at the National Cancer Institute. There, Di Lauro began a career in molecular biology that went from studying gene regulation in bacteria to understanding regulatory networks in mammalian organogenesis. Along the way, he was a group leader at the EMBL, a professor at the University of Naples, Federico II, served as president of the Stazione Zoologica Anton Dohrn, and was even at one time posted to the Italian embassy in London. Roberto Di Lauro has been an EMBO member since 1992. He's currently retired from research, but still works in science evaluation as a member of the National Committee for Evaluation of Research in Italy. We talked about molecular biology, the challenges of evaluating and funding different types of research, and the occasional uses of having a minister's cell phone number. Welcome to the EMBO podcast.
I have a degree in medicine. I've never seen a patient in my life because on the fourth year medical school, well, some friends say that was good for the patients. But I entered a research laboratory at the fourth year medical school, and I never left the lab. My main interest has been molecular biology since I started. At the beginning, I worked on gene expression in bacteria, and then I worked on cell type specific gene expression using as a model the thyroid cell, and then from our finding moved us to work on medical genetics because we discovered genes that were involved in congenital defects of thyroid function. And we also studied in mouse models the development of the thyroid, because the genes we found that were involved in cell type specific gene expression were also involved in the organogenesis of the thyroid gland. So the last part of my career was devoted to study organogenesis. And as I said, now I have shut down my lab and I've dedicated myself to science evaluation, and that's what I'm doing now in this national committee.
And this fourth year transition from medicine into the lab, was it in the nature of an epiphany, or did you know from the beginning that you were interested in scientific research rather than medicine?
That's a good question. I actually went into medicine because, you have at one point to decide what to do when you grow up. And when I was in high school, my science teacher, and I still remember it, made a comment on these scientists that were trying to cure diseases like cancer and so on. And so that was the comment that tipped my interest in medicine. But from the beginning, I was really interested in research. And in the first year medical school, I read a book on the new discoveries of the genetic code. I am not so young. the discovery of the genetic code, and that attracted my attention immediately. So I started to read books outside of those that were required for medical studies, and I fell in love with DNA, RNA, genes, how genes are expressed and how they function, and I never left that interest.
That interest in how genes are expressed and how they function led the newly minted MD to the Laboratory of Molecular Biology at the U.S.'s National Cancer Institute. A couple of days before Christmas 1971, the NCI received a big boost when President Nixon signed the National Cancer Act, kicking off the war on cancer. Roberto Di Lauro arrived in Bethesda in 1974.
As I said, I graduated in medicine, but after two years after graduation, I obtained a postdoctoral fellowship at the NIH, and that's where for 4 years I studied gene expression in bacteria. I was working on the regulation of the galactose operon in E. coli. Toward the end, this was the period in when restriction enzymes and genetic engineering was starting. So the last year at NIH, I stopped working on gene expression in bacteria, and since I became an expert I became an expert in genetic engineering, the head of the lab asked me to help cloning the collagen genes. So I moved from the galactose operon to collagen gene, but was mostly a technological competence that I had acquired working in bacteria. So I worked for the last year at NIH on cloning the collagen, helping cloning the collagen genes. And then when I came to Naples after 4 years at NIH, at the medical school, and when I started my independent career, I used that expertise to clone genes that are specifically expressed in the thyroid gland, in particular the thyroglobulin gene. And since then I worked on thyroid. Because we first cloned the thyroglobulin gene, we were unlucky because it was one of the largest gene known. So it took us a long time to clone the gene, and then after cloning this gene that was about 200 kilobases long, the message is 10 kilobases. The gene had lots of introns and extremely long. Then we concentrated on the regulatory region because we wanted to understand why the thyroglobulin gene is expressed in thyroid cells and essentially in no other cells in a mammalian body. So we concentrated on the regulatory region and tried to reproduce this cell type specificity in tissue culture. And then we focused on a region, and then on the protein binding to those regions, we cloned two transcription factors, the gene for two transcription factors that were involved in cell type specific expression. And then we discovered that these genes were also important for organogenesis. And so our interest moved to organogenesis. And since I shouldn't make a mistake, about 1 in 10,000 children are born with the congenital defect in thyroid. Then we searched in these patients whether there were mutations in this gene. So it actually, we had the moment of popularity because two of our genes were involved in, we found mutation in two of the genes that we have studied in patients with congenital thyroid defect. So there were two Nature Genetics paper, which I'm very proud.
So you started in medicine, went to E. coli, and then ended up in human again.
And then went back to human, yes.
Jacques Monod said in an oft-quoted but rarely sourced aphorism, what is true of E. coli must be true of an elephant. During De Lauro's time at the NCI and in the years immediately after, eukaryotic genetics threw up many surprises, variations in the structure and regulation of genes in elephants that were not predicted by the previous work in phage and E. coli. De Lauro's paper in Nature characterizing the galactose operon was entitled Unusual Location and Function of the Operator in Escherichia coli galactose operon. That unusual location for a regulatory element was a whopping 60 base pairs away from the transcriptional start site. The introns he mentioned were entirely unknown when De Lauro moved to the US.
Let me tell you a story. While I was at NIH, and I was still working on galactose operon, there was this very competent and an excellent scientist, Shirley Tillman. She gave a seminar at NIH, and unfortunately I could not go. And at that time, was the beginning of cloning of human genes. So she cloned the globin gene, the beta globin gene. And so people went to listen to her seminar, and she presented this amazing discovery that when looking at the electron microscope of the hybridization between the message of the globin message and the gene that they had cloned, there was a piece of the gene that was not in the message. So, And they were, and I have to admit that my first comment was, this must be a ridiculous artifact of gene cloning. Was the first discovery of an intron.
I mean, there is a recorded lecture with Richard Roberts with exactly the same reaction, where he told this postdoc, you made a mistake, go back and do it again. And then he said, you made the same mistake again. Now I'm going to have to show you how it's done. And then lo and behold, introns. And to come a bit to issues related to science policy, but starting at the same experience that you've had in the way you've started in science, this moment where you arrived at the NIH was also the moment of probably the largest non-military scientific mega funding initiative, which was the War on Cancer, had just been launched 2 or 3 years before by President Nixon. Did that influence the way you think about how science should be funded in either negative or positive ways?
Well, actually, that's a good question. The lesson that I learned from there was I was working at the Cancer Institute that was established in this large program of War on Cancer. But in the Cancer Institute, I was working in a group that was working on the galactosoperon, and together in the same laboratory, in the same department, there were others working on bacteriophages in the Cancer Institute. The lesson I've learned from that is that the Americans learned that they had much more to learn about basic concepts in order to fight cancer. And this is something that is still part of the way I think about science, that science, sure, we should try to translate what we discover into solving problems of the world, of humans, of the world in general, but we cannot do that properly if we do not know enough. So the lesson I learned from that even in this war on cancer program, the Americans were smart enough to leave enough funding to do basic science, to learn the fundamentals on how genes are made and how genes work. And that has been essential, as we all know, because without those discoveries, without people looking at the basics, we wouldn't have the human genome program, we would have genetic engineering, we would not have the discoveries of genes involved in diseases, we wouldn't have gene therapy, we wouldn't have many things that derive from those basic studies. It's difficult to make a proper balance. I have been a strong defender of basic research. However, now I think that sometimes we are a little bit snobbish about applied research. We should teach people that it is important to translate knowledge in something useful. We should not only do what some people call useful research. We should know more. This is our main job. But we should also look with attention at the possibilities of translating this knowledge into useful application. And there is actually a program that is done. I heard once a conference at the Royal Society in the period I was in London as science attaché. And this extraordinary person, who at that time was president of the Royal Society, Paul Nurse, talked about this in a meeting. Now I don't remember what was the subject of that meeting. It was a Japan-UK meeting on applied research. And also Paul Nurse is a strong supporter of basic research, but he said we should work in building bridges between knowledge and application. And for example, the Royal Society has a fantastic program that I have been trying to launch also in Italy, but I have not been successful up to now. The program is the Royal Society gives fellowship. They are called the University Research Fellowship to scientists on the basis of their creativity, innovation, ideas, nothing to do with application. They reward people that bring new contribution to knowledge of nature. But then they offer to these people program a course to understand the basic principle of business, so that these people have some basic elements in the case they run into something that might turn out to be useful, that they know how to do it. And I think this is an extraordinary way. This is really a brilliant, simple way to try to build those bridges that Paul Nurse was talking about, which I think are useful. I think that we basic scientists, I am a basic scientist, should not be snobbish about it. We should not disregard it.
Well, and I think there's also one selfish aspect, if that's the right word, from the scientific point of view, which is, so, for example, I teach a lot of MD, PhD kind of settings, and there's also a literal translation in the other way that is not talked about enough, which is the clinic and the real world is also often the source of things that become very interesting basic science. And so this isolation also, so we going before molecular biology, we have DNA because, Frederick Griffith was interested in the epidemiology of bacterial pneumonia. And it was an entirely practical problem that became a scientific problem. And this is spread out through agriculture, through medicine. The real world is also a great source of very good science. So it really is translation.
You're right. It's both ways. And on this communication, I think there is still much work to do.
I'm very interested in this period where you were scientific attaché because, from the movies, we usually think the attaché is the spy. So the cultural attaché is always the one with the umbrella with ricin out poisoning Bulgarian dissidents or something. What does a scientific attaché actually do in there? For example, what did you do in the London embassy?
Yeah, the role of the scientific attaché is to promote a connection in the scientific and technological world between the country in which you are and your home country, Italy. So my role was to promote a connection between UK science and Italy. It has been a fantastic period of my life, I have to say. Also helped me to, and it's difficult for scientists to leave what they're doing. So they retire and then they suffer and they go back. They still go to the lab, and no one wants them because because they occupy a space, and other people want that space. At any rate. So that helped me to say, all right, now I change job. I finished being a scientist. I go work for diplomacy. So apart from this personal comment, it was a fantastic 4 years. I only did that for 4 years. So I had to assist the ambassador every time he had to deal with something that was somehow related to science. So I had to prepare for him info. But I also have met more people because while a scientist tends to be focused on his own problem, in that period I had to be completely unfocused because I had to cover everything from nuclear fission to climate change, which put me. I learned a lot. I have met more people in that period that I met in my previous scientific career, talking about lots of things. So it was nice to cover so many things. My major accomplishment and my strategy was to use, since there are lots of Italians working in UK, so I used those Italians to connect to all institutions in UK. So every time I needed information, I needed something, I was talking with my fellow compatriots, in addition, of course, to UK scientists. And I also try to promote a better connection between the Italian working abroad and our home country, also because UK science, and that perhaps could be a nice way to connect to the second part of our conversation, because I was in love with the way science is organized in the UK government. I learned how science there is organized, how evaluation of science is organized, how the distribution of funds is organized. Nothing is perfect, but that was so much better what we do here. So I tried to send a message toward Italy on how things should be done. I was very much impressed, for example, by the fact that in UK there is a science expert in every department of the government. There is a scientific advisor in every, so that the decisions, perhaps they do not depend always on the scientific expert, but at least they try to use what is known, hard science, for the political decisions.
According to the EMBO Facts and Figures feature for the country, there are 1.8 million people in Italy involved in the life sciences. Italian R&D spending amounts to about 1.5% of its gross domestic product. Italy has 116 EMBO members. Professor Di Lauro and some of his fellow Italian EMBO members recently led a successful effort to lobby for changes in the Italian science funding system.
Funding of science in Italy is done with programs that are very much like the program of the European Commission, where the funding is done to large networks. And there is one important reason to do this is to reduce the burden of evaluation. Because if you fund large networks, then you can fund 20 people with one evaluation rather than evaluate 20 people that apply individually. So actually, this starts from EMBO, because a group of us, of Italian EMBO members, we asked the Italian EMBO members whether we should get ourselves organized to have an impact on how science was run in Italy. And so we had an election. We are not organized as an association. It's sort of a steering committee. We had an election among the Italian EMBO members, which are 100 something, now I don't remember. We had an election to establish this steering committee of 5 members, and I was elected among the 5. So with these colleagues, we got together and said, well, if we want to have an impact, what should we do? So we decided to focus, and we identified as an important objective to try to reach was to establish an individual funding for individual scientists, which was not present. We elaborated a small document where we touched also on other points, how the evaluation should be done, and the fact that the funding should be regular. There should be at least a call once a year, which was not the case, not even for the funding of large groups. So we wrote this document, said in Italy this is missing, there is in all other countries of the Western world, at least, the most advanced countries in the world. And we sent this document to the minister. And the minister was gracious enough to ask us to go and talk with her. And so we gave her this document. And she said that she was thinking about it. Now, how much was our meeting with the minister and the presentation of this document instrumental for the launching of this program, which is called FIS, F-I-S, Funding for Italian Science, which is a program to fund individual scientists. I don't know, we like to think that we made at least a dent or a contribution for the program to be launched. this program did not exist before, and this goes to the credit of the present minister, which unfortunately is going to leave government because, as you know, there are elections in Italy, and the government is out of business. But this has been a great contribution that this minister has left, and a difference from the many other funding that there are now for the Italian research because of the PNRR, the Italian Plan for Research and for Recovery and Resilience. This money that she put on this program is not a lot. It's 50 million euros for the first year, but will go to 150 million euros for the next year. These are money that are from the ministry, are not money from this European plan, extra European fund that we have received. So is not a program that has an end. Once it started, some funds are from the ministry, and that's what we said the ministry, because the ministry said we don't have much money. We actually made an estimate that we needed for this program about 800 million euros. She said, I don't have that fund. And we said, well, the important thing is to launch it, because once it's launched, then there is a program and can always be increased.
And it's a huge step forward. And I wonder if there is any advice you would give to other working scientists, working researchers, if they feel that they would like to take an initiative of this type. How to approach the policymakers, so it's not unusual that people will get together and write a position paper or a plan. It is unusual that to whatever degree, as you say, but that it contributes to change. So it is actually effective. Is there any advice you would give to move from lamenting the state of things to changing the state of things, specifically for scientists?
Yes, I can only. There is not. I can give a little advice. I can give is be courageous, because we prepared this document. We wanted to send it to the journals, and then we said we should send it to the minister. But how do we send it to the minister? She would receive tons of messages. Why should she look at something like that? How can we do it? Who do we know that knows the minister? And actually, looking in my agenda, I find the cell phone of the minister, because the minister worked for the National Research Council before, and we met briefly. And I am a little bit reserved. They said, yes, I have met briefly, but now this person is a minister. We should not. Can I use her cell phone? So at the end, after discussing with 5 colleagues of us, I took some courage and I sent her a message. I was not talking with the minister for the last few years. And I said, we have prepared the program. Where can I send it to you? Sorry to disturb. Well, can we? And she was nice enough to say, sure, send me a mail with the program, and why don't we get together? So, there is no general rule on how to interact with politicians. So I was lucky enough that I had a personal contact, even though the contact was weak. But I used it and worked. There is no general advice that works for all countries. So if you have a cell phone, use it.
We need to talk about the relationship between exceptionally good, excellent science in a few centers and equally important good science as it is conducted in many labs at several institutions in the country. The country in question was Italy, and these are the words of Professor Roberto Di Lauro in a recent EMBO interview. I asked him about how one should balance the goal of supporting outstanding, cutting-edge research and the need to nurture and support what, for lack of a better term, we could call normal science.
Tough question. It's not easy to answer this question. I do agree with you that there is a level of excellence and there is a level of normal. And we have to find the proper way to define this thing, because there is no good science and bad science. The science has to be good and has to be solid. However, some people have the opportunity to work in institution or have the funding to ask very ambitious questions. There are some other scientists that don't ask very ambitious questions also because they don't have the means to address those questions. However, they do a very important job, for example, teaching. I mean, there are some university professors that devote most of their time to teaching. There are research institutes in Italy that are located in difficult part of the country. And they need to be supported because they have a fundamental role. One important role, I think, is they capture brains. Because if there is a network that is diffused through the country where people do some research, that is a great opportunity for young people to be in contact with research. And among those, the excellent can emerge. In addition, there are so there is teaching, there is capturing brains, there is also the attention to local issues, which is an important role that some research institution might have, and that are not necessarily excellent from a scientific point of view, but are important for the local communities. So I think that we should look without being snobbish, we should look at both networks, and we have to generate ways in which the two networks help each other. The normal network helps by dedicating to teaching, to capture brains, to be present locally. But they help the excellent networks because they provide those brains to the excellent networks. And the excellent networks have to support by hosting people from these labs, by constituting centers where people can go and talk to the excellent scientists, to the scientists that are in contact with the most advanced science. There is a polemic these days because Italy has launched, at distance of several years, two centers of excellence. One is the Italian Institute of Technology in Genova, and the other one is the Human Technopole in Milan. I think I am a great supporter of this initiative, and this applies also, for example, to EMBL. Because these are centers of excellence, and the countries contribute to this center of excellence. But it's clear that the center of excellence, because excellence cannot be diffused, it costs too much to diffuse excellence everywhere. So one has to be in peace with the idea that there are excellence is costly and can be concentrated only in few places, but these few places need to establish contact with the normal network that have other means. So, but to go back to your question, which was more insidious, should one put aside some money for the normal network where one should not be excellent? I think yes. My answer is yes. One should define some programs. For example, in one of the funding programs in Italy, there is an allocation specific for the South, where only people that work in institutions that are located in the South. Since the South is poorer, there is less possibility to find external funding. So the government has decided to allocate 40% of the funds to the South, and you can apply only if you are working in an institute in the South. I welcome those initiatives because it helps promote science and research. So, initiative of this sort, where you allocate some funds for specific programs which of course evaluation should be rigorous, but the aim of this should not be the most advanced science or the most excellent science.
Well, for me, I have, and I know the boat has gone too far in the way we use the language here, but I have a bit of a problem with the way the word excellence was chosen, because I think it's more what you mentioned, my personal opinion, advanced or cutting edge. But there are
Yes.
people working on local problems who are doing extraordinarily difficult and very, very challenging science, but in the end, the outcome is improving soil quality somewhere in Sardinia or something. Um, I wish we hadn't picked the word excellence to run with, and I wish, my personal opinion is advanced, which you used, or cutting edge, which is a scale problem, which are different kinds of challenges. I am much more comfortable with. Also because I am originally from Brazil, and and then I was an editor at Journal of Experimental Medicine for a while. And for me, if we were going to rate excellence, if you can produce a high quality paper in the University of Paraíba, where you built your own spectrophotometer, and 16 referees told you that a native English speaker should look at your paper, I am much more impressed by that than by the 16th paper from that Center of Blood Research lab this year, where you came in, the mouse was there, the reagents were on the table. So but this is the way the world is. But I think the word excellence loads into this assumptions about the quality of the work, the idea of normal, of course, comes from this kind of Kuhnian view of science, and I think in that case it's more apt. Is the things that we know how to do, but they are hard. They are very hard day-to-day problems. We all know outstanding people who stayed in their regional institutions because they thought that was important. And I think part of it's going to generate more problems than it solves in the long run to use the excellence label, because of the sort of rhetorical pushback that you could expect to get in that sense.
So I agree with you, and I think that we should, advanced is better than excellent. As I agree with that. We should also find a different word from normal.
Yes.
Because people don't like normal.
Absolutely.
I am not normal. What do you mean?
Absolutely.
And in fact, this is actually something we talked with my friend Ian Matai, who is directing the Human Technopole. And at the beginning of, we're discussing on these polemics. I was in Italy. Why so much money for the Human Technopole when we have the Italian research has no funding? I disliked that argument because I think advanced center help everybody. And to have an advanced center like the EMBL in Europe, Human Technopole, like some universities in UK, like the Howard Hughes Institutes in the United States, and so on, is important because there is a place where knowledge, expertise, machines, advanced machines are concentrated. And if people from the other network, which we don't like to use the word normal, want to have access to, at least they know where to go. They have somebody to talk to. They have a place where to get advice. So this relation between the center, advanced center, and the basic research infrastructure and academic infrastructure in every country and in Europe is an issue on which perhaps the EMBL or EMBO perhaps should make a position paper.
You can read a recent interview with Professor Roberto Di Lauro at embo.org. It's in our Focus on Italy feature, a part of a new collection of EMBO member state profiles, which so far includes Finland, Estonia, Turkey, Poland, Greece, and Denmark. Each focus feature includes interviews, fact sheets, and a summary of EMBO activities in the country. Thank you for listening to the EMBO podcast.